Okay, welcome to a rare snow day edition of SPMC350. We're going to talk about residuals today, which are part of correlations and regressions. We are going to extend just a little bit beyond there because we talked about in class on Monday how a regression analysis will create that y equals mx plus b line that predicts what the outcome should be. So we could predict the final score, knowing a couple of things. In the assignment due today, you were to look at the score differential, basically was the score positive or negative in a team's favor, i.e., did they win or lose, and the turnover margin. Now, the trick to that assignment was finding the correct turnover margin, making sure that you were subtracting. You first had defensive turnovers because they're good, minus bad turnovers, which are offensive turnovers. If you did offense minus defense, if you go out and throw 5 interceptions, but your defense recovers 1 fumble, the real turnover margin is -4. It's 1 minus 5. You are 4 turnovers in the hole. But if you flip that around, if you put total turnovers first and defensive turnovers second, you got a +4, and that made your numbers all kinds of wonky because that's saying turnovers are good. You want to turn the ball over. We do not want to do that. So you then created a regression analysis out of that. That regression showed that you can predict something like 27% of the outcome of a game just knowing the turnover margin. And, there's an opinion question of whether or not that's a lot or not. And the answer is it's kind of both. You can't predict an entire game based on turnovers, but knowing almost 30% of the outcome just purely based on one number, that's a lot. That's a big chunk. So whatever you put in that answer, you're going to get the points. Don't worry about that. But let's talk about residuals. I figured out why my correlation that I tried to do in class didn't work the other day when I tried to create these residuals. And it's a fun little answer here, and I'll show it to you in a second. So we're going to start with the tidyverse. I'm going to load in the logs data that we've used before. This is every basketball game. This is up to the Ohio State game. It includes the Ohio State game. So we have not played since, so this is every Nebraska game will be in here. So I'm going to do something similar to what we did for the assignment today. I'm just going to create a new data frame called diffs. I've got a score differential, which is the team score and the opponent score. I've got a shooting differential, which is the team field goal percentage and the opponent field goal percentage. And I'm going to create a turnover differential here too. Nebraska's been a little sloppy with the ball at times, so let's look at team turnovers minus opponent turnovers. Is that predictive in a basketball game? Because the answer here is yes. And of course it is. The reason mine didn't work in class the other day is because there is 2 games in this whole data set where the shooting percentages are blank. So what this filter does is just get rid of any shooting differentials that are NA, that are blank. So you will not have to do this for the assignment due Friday. That data is already clean and clear, and you will not have to worry about it. But occasionally that comes along, and NA data will screw you up. Okay, so I have my diffs data, and now I can create a linear model out of it. So I'll call this a fit just because it's easy. LM, I am doing the score differential is approximately modeled by, let's start with the easy one, shooting differential. And my data is diffs. So note, if I'm asking you to make things in mutate, you're gonna use them later. So anytime you're using mutate and you're answering a question, this should be your immediate sign, your immediate hint that these are gonna come up again. I don't make you make things just for nothing. I didn't spell this right. Shooting. There we go. Okay, and then I forgot to do the summary. And there it is. So is it random? No. Is it predictive? Yeah, like 70%. You can predict 70% of the outcome based on the difference in the shooting percentages in a game. So that's a lot. That's really big. But how well does this model do? And this is what residuals tell us. So we can, of course, look at this as a graph. My data is diffs. My aesthetic is, I call it score differential, and my y is the shooting differential. And yeah, really tightly clustered there, which means that's what an r squared of 70 looks like. It's, you know, very close. And I can add my line of best fit by just doing that. And that, we'll get into this much later in the semester. But there's my y equals mx plus b right there. So this line here predicts. Now what a residual is the distance between this dot here and this line. So this is a team that won by more than 50 points, but the shooting differential here was almost 0. They barely outshot each other. And I'm going to do one thing very quickly because I remember this causing me problems the other day. For some reason, the residuals act really funny if you don't do this. Basically, I'm going to convert it into a percentage. Doesn't change anything there, but it'll just change the label over here. So now it's a percentage. So everything's still the same. Here's a team that won by more than 50 points, but had a single percentage point difference in shooting margin, the shooting differential between each other. So yeah, weird games happen. That's why we play sports. Like, that's the fun part. But we can look at how well our model predicts things by looking at the residuals. So I have my diffs model. I'm going to mutate 2 new columns. I'm going to call it the predicted score, and I'm going to use the predict function, and I put my fit in there. And then I'm going to do my score residual. And I'm going to put my fit in there. The function is residuals. Run that, it works. I've got some columns way out yonder way, but this is where select can come in handy. So let's do the select. Let's do the date, the team, the team score, the opponent score, the score differential, the predicted score, and the score residual. Okay. So Abilene Christian in their first game won 107-74, a 33-point score differential. The predicted score differential was 38. So based on the shooting, Abilene Christian actually did about 5 points worse than the prediction would have said they would have. The next game they lost by 23. They should have only lost by 16. So again, they kind of underperform. They underperform here, they underperform here relative to the model. The next game they won 101-55. They outscored them by 46. Here they were actually overperforming. So they overperformed by 9 points. So you can get an idea here. If it's negative, it's underperforming. If it's positive, they're overperforming. So obviously, I don't know about you, I don't give a rat's ass about Abilene Christian. So I'm going to filter where the team is equal to Nebraska. And, okay, Texas Rio Grande Valley. Tell you what, I'm gonna drop the scores out here, and maybe that will cram it all into one window that we can reasonably see it. Yeah, there we go. So we beat Rio Grande Valley by 20. The prediction would have been 15 based on our shooting, so we overperformed. We overperformed by 5 points against Bethune-Cookman. We only won by 5 points. The way we played against Bethune-Cookman, we should have lost, according to the predictive model. That's where this gets fun. If this is a negative number and this is a positive number, St. Mary's, here's another one. We lost by 3. The model says we should have won by 4. We underperformed by 7 points. FDU, we should have only won by 4.5. We won by 21. We wildly overperformed in that. So let's go down here to Ohio State. A little bit of an underperformance. We should have won by 13. We won by 8. Beating Washington by 14. We should have only won by 8. We overperformed. We beat Oregon by 6. We should have done it by 15. We actually underperformed versus Oregon, which is interesting because we beat them pretty solidly. We did almost exactly what you would expect given our shooting against Illinois. Predicted to win by 6.5. We won by 6. That, you know, if you're getting less than 1 here, that's pretty dead on. Lost by 28 to Wisconsin. Should have only lost by 17. Underperformed. USC, we lost by 5. Should have won by 7. Underperformed. Maryland, lost by 3. Should have won by 3. Underperformed. Rutgers, lost by 3. Should have lost by 4. We actually overperformed versus Rutgers, which is kind of nuts. Purdue, we get blown out. Shouldn't have. Well, we should have lost by 19, according to this model. So you get the idea. Nebraska's had a really up and down season. We've had a couple of games where here, UCLA, we beat them. We should have lost. We beat them by 8. We should have lost by 7. We overperformed our metrics by 15. At least our shooting metrics in here. That's pretty great. That was a fun game right there. But yeah, you get the idea. This is a statistical way to prove whether or not a team is under or overperforming. And you can do this with lots of stuff. Now, if we go back here and I change my fit very quickly, where am I at? Up here. Instead of shooting, which we know, a lot of people have complained about turnovers. Okay, fine. We'll swap in turnovers here. We'll run this. Is the correlation between the outcome of the game and turnovers random? It sure is not, but it only predicts about 18% of the difference in the score. Pretty low. That means there's, 82% more to the game than this. Okay, this is shooting percentage that's really, really pretty predictive. It's only like games that really get weird. Most of the stuff is right around the line here. If I do this with turnover differential, my numbers are scattered around a lot more. There's a lot more, here's a game where the team was greater than plus 20 in turnovers and lost by 40. The other team was turning the ball over left and right, and they were getting them, and they still lost by a ton. Here, this kind of gap you see here is 0. You get this kind of pattern when you have numbers that don't have decimals. So you can't have half a turnover. But this is a negative relationship. The lower the turnover, well, actually, did I screw this up? I did. I did it backwards. Look at that. I told you not to do that, and then I did it. I'm like, why is that a negative relationship? That shouldn't be that way. Well, yeah, of course it shouldn't be that way. Shouldn't change anything here. It's still only about 18%. But if I run this now, there we go. The more positive the turnover differential, the more points you score. There's still teams down here who had, plus 15 and still lost. That's kind of crazy. Here's a team that was plus 26 or so and won by 100. That's yikes. That's not good basketball. Okay. I can do this same thing again and predict, and your residuals here are going to be a lot larger. Against Michigan State, we lost by 37. We actually took care of the ball pretty well that game, so our model says we should have won by 6.5. That's a 43-point miss for the model. That's pretty bad. This is what it looks like when you have a model that predicts about 18% of the variance. You get some pretty wild misses. Lost, should have lost. That's pretty. St. Mary's might be able to say even that this was the reason that we lost against St. Mary's. I'm trying to find one here real quick. Here we go. Indiana. We won by 17 based on turnovers. We should have lost by 5. Murray State. We won by 17. Should have lost by 4. Should have lost to Ohio State. Should have lost to Oregon. Should have beat Rutgers according to turnovers. We only should have lost by 8 to Purdue. I wish. Lost by 10 to Iowa. Should have eked out maybe a win. So, yeah. This is what you get when you have a model that's not terribly predictive. Later in the semester, if we have time, if everything's moving along, I'll talk about multiple regression. The regressions we've been doing are very simple. They're just two things. We're going to, compare this to this because they're easy to grasp onto. There is multiple regression where you can add in other things. We could, in fact, do that here. This is the shooting. Really, I just did a multiple regression. I can now predict 80% of the outcome of a game. I can't graph it because I can't graph multiple things, but I can add residuals here. And notice they get a lot closer. FDU, we shouldn't have won by as much. That's a pretty good miss. The Creighton game, we should have won by more. I wish we would have. Yeah, it's actually not too bad here. It does say we should have lost to Ohio State. I'm sorry, we underperformed against Ohio State. We should have won by 9. Nailed these pretty well. Should have beat Washington by 12 and change. We won by 14. We should have beat Oregon by 6 or by 12. We won by 6. We should have beat Illinois by 19. We won by 6. So the combination of turnovers and shooting actually does a pretty good job here. And numbers still mean the same thing. We either under or overperformed. Here we overperformed against UCLA by a pretty good ways. We should have lost by 4.5. We won by 12. That's Pinnacle Bank magic right there. So that's residuals. It's really just adding on 2 columns for the actual prediction that your model would have made, and then the difference between that prediction and what happened in reality, and then its interpretation. If this number is negative, you underperformed. If this number is positive, you overperformed the model. residuals give you a really powerful tool to do some description of how a team played given the inputs. So questions, holler at me on Slack.